right, so when we're looking at projectile motion, one thing that is very critical for someone in projectile motion, like a human cannonball, is getting delta x right, because you get delta x right, not a good thing. So that's a critical part that we're going to look at here. Now, some of the factors that go into this, are the initial velocity, what angle that the projectile motion is. And if you remember with projectile motion, critical thing to remember is that Vx stays the same the whole way. Vx all the way stays the same, right? So if you look on your equation sheet, this is the only equation that's given, right? For the x direction, the x velocity times time, because there's no acceleration in the x. But in the y, initially it starts like this, but then it gets smaller and smaller and smaller, and then Vy at the top is 0. And that can be very helpful as well, because we can figure out what the velocity is halfway. Okay, so again, it'll spend half the time going up, half the time going down. And yeah, we can use that to be able to know what's going on. All right, so let's go ahead and set this up with a soccer ball that's going. Vx is 9.5 meters per second at an angle of 25 degrees. And that's the hypotenuse, okay? And we want to find out, how far delta x, right? So the first thing we got to do is figure out what Vx is and figure out what Vy is. So Vx and Vy. Now we're going to need our trig functions for that, which is 25 degrees. We've got, our hypotenuse is 9.5 meters per second. So yeah, go ahead and pause the clip and solve for your Vx and Vy. And when you're ready to check, you can hit play to continue. All right, so for Vx, we should get 8.61 meters per second. This is the adjacent side. And we have the angle here. Then we have on the y, that's the opposite side, 4.01 meters per second. So the whole way, it's going to stay 8.61 all the way across, 8.61. So delta x equals Vx times time. We know Vx is 8.61. We want to know how far it goes. That's our goal, but we don't know how much time is in the air. And that's where we can use our y information. We know Vy initial is 4.01 meters per second. Vy at the top is 0. So V final is 0 at the top. We want to know how much time that it takes to go across, and we also know acceleration is negative 9.8 meters per second squared, right? So yeah, go ahead and pause the clip. See if you can use one of your 3 constant acceleration equations. It's not going to actually be the one underneath projectiles. It's going to be above that. It's going to be one of the constant acceleration equations. You're going to find time halfway, and after you find time halfway, then you're going to be able to multiply that by 2 and then get the time the full way. But see if you can figure it out, and when you're ready to check, you can hit play to continue. All right, so we should get 0.4097 seconds halfway. We multiply that by 2, so the full time is going to be 0.8193. So this final velocity equals initial velocity plus acceleration times time will help us find the time, again, halfway, and then multiply by 2 to get the time the full way. And then Vx times time, which is, rearranging our basic velocity equation, it's going to go 7.5 meters. All right, so if you remember with just basic force, force is a push or a pull, makes things accelerate, right? So you can slow things down, you can speed things up, and you can turn things. And so when we looked at change in direction, that was circular motion, but speeding up and slowing down was a big part of what we looked at as well. Now, Newton's first law, remember, is an object in motion will stay in motion at constant speed, or an object at rest will stay at rest as long as there's no net force. If there is a net force, you will have an acceleration. This is called the law of inertia. Now, the second law is the one that's a little bit harder to remember. Remember, F equals ma, right? So if you have more force, you have more acceleration. If you double force, what's going to happen to acceleration? It's going to double, right? So now, if you have more mass, let's say you doubled mass or tripled mass, you would have 1/2 or even 1/3 if you triple the mass, the acceleration, because the more mass you have, the harder it is to accelerate. And the direction of that acceleration is going to be in the direction of that force. Okay, so let's do a basic force problem. A person kicks a 0.46 kilogram ball with a force of 5 newtons and towards the east, and we want to find the acceleration of the ball. So yeah, go ahead and pause the clip and give this a try. When you're ready to check, you can hit play to continue. All right, so pretty straightforward there. Now, we have to have direction with acceleration, right? So, you know, the force is to the east, the acceleration is to the east. All right, now on this one, we have a kite. We have the force of lift, which is positive 12 here. We have the force of gravity, which is negative 7 here. And then the wind force is from the left to the right, positive 3. Now, we want to find out the net force of the system. Now, if you remember here, we have to get the total y and the total x. And then what we'll do is we'll bring those together to the coordinate axis and figure out the net force. So we'll have blank newtons at blank degrees above the x-axis, above the positive x-axis, okay? So yeah, go ahead and pause the clip, give this a try, and when you're ready to check, you can hit play to continue. All right, so positive 5 newtons in the y, positive 3 newtons in the x. So we can set up the x first here. You could set up the y first if you wanted to. So 3 to the right, then 5 up. We should get a resultant of 5.83 newtons at 59 degrees above the positive x-axis. Okay, now what is the acceleration of it then? Well, F equals ma, pretty straightforward. We know the mass, we know the force. So it's going to be in the same direction. That's part of the second law, right? Where, you know, the force and the acceleration will be in the same direction. And so, yeah, so there we got that. All right, so finally, what is a man's mass if, or what's a man's weight if their mass is 68 kilograms? So go ahead and pause the clip and do that. When you're ready to check, you can hit play. All right, so 68 kilograms, F equals ma. So remember, weight is the force of gravity, which is mg, mass times 9.8, and we get 666.4 newtons is the weight of the person.